So for this trig identity here, we want to begin with the more complicated side. Again, more complicated. What does that mean? I mean, I'll leave it up to you, but intuitively, any side that has more stuff in it. And I think in this case, the left-hand side has more stuff in it. So let's start with the left side. So we want to show that the left side is equal to the right side by using any one of these, trig identities that we've proved so far. I'm just going to copy out the equation here. It is cos x plus cos x tan squared x. Sorry, not the equation, just the left-hand side. And I'm going to start doing some replacements. So what can I do here? Well, again, I want to get 1 over cosine. Is that possible right now? Well, I'm going to take a shot in the dark here. Again, I have not done this question in a while. And I'm going to try to get my sine and cos, out of tan squared. I don't know, I'm just going to give it a try. Because I know tan squared has a cos in the bottom, so hey, it'll cancel out with one of them at least. So I have cos plus cos times, I have sine x over cos x, and again, this is all squared, which gives me, again, cos x plus cos x, oh, forgot the x up there, times sine squared x over cos squared x. Let me just write that. Cos squared x. Okay, so some cancellation can be done. I'm going to cancel this with one of these here, and I am left with cos x plus sine squared x over cos squared x. Now at this point, well, actually not cos squared x, just cos x. It's kind of like, what can I do? I still need to get that cosine in the denominator. And I have two fractions going on here, right? I have the first and the second. How can I combine them? Well, let me multiply top and bottom of this first guy by cos x. Again, I just want to be able to combine these fractions together, and to do that I need a common denominator. So I multiply top and bottom. In my numerator I'm going to get cos squared x, and that'll be over cos x. That's all plus sine squared x over cos x. And now I can bring them together to give me cos squared x plus sine squared x all over cos x. And I think you can see where this is going, because if you look over to the table here, I think that Pythagorean identity is going to come in handy for this guy. Let's bring our work up here. My numerator, oops, wrong one. My numerator, all that stuff, can be represented by 1. So what I end up with here is 1 over cos x, which is just the right side. And that completes our proof. And also, notice how we kind of just organically went about it. I had no idea where this was going, and there probably is a shorter way to do this, but hey, it works, and that's good enough at least to start.